going to solve it. Right, now it is one example problem. So this example problem is what? It is a connected graph and it is a weighted graph, and these are the weight or these are the cost from path. Now the cost of 1 to 2 is 20, the cost of 1 to 3 is 30, the cost of 1 to 4 is 10. Like this you have to assume. Now, so what we are looking for? We wanted to get the minimum cost. Now for this what we will do is, we'll find out the cost of the matrix first of all. So cost of a matrix in traveling salesman problem, applying branch and bound, the procedure is different. The procedure is what? We'll reduce the matrix, find out the minimum value in the row and subtract it. So it is 10 and it is what? 2, it is 2, it is 3 and it is 4. Okay, now subtract 10 in this row, subtract 2 in this row. So if you do so, your matrix is what? Infinite 10 in 20 0 1, 13 infinite 14 2 0, 1 3 infinite 0 2, 16 3 15 infinite 0, 12 0 3 12 infinite. This is what your reduction of row. Now reduction of column also we have to do. For that, write the minimum values in the column 1. So minimum is 1, minimum is 0, minimum is 3, minimum 0, minimum 0. So here what are the minimum values? 10, 2, 2, 3, 4. Add all this together. So this value is 21, this is 4. Finally it is 25. Reduction cost is 25. Reduction cost is 25 and this is what your reduced matrix. Now what we are going to do with this? Now what we are going to do with this is, you are going to find out the state space tree. So what is your state space tree? Will tour starts with one vertex. Now he can visit 2 or he can go to 3, he can go to 4, he can go to 5. So as far as this example is considered, make sure that these are node values. That is 1, 2. Second node is what? It describes the path from 1 to 2. Third node describes the path from 1 to 3. Fourth node describes the path from 1 to 4. Fifth node describes the path from 1 to 5. Now you have to find out the cost of 1 to 2, 1 to 3, 1 to 4, 1 to 5. And whichever cost you find it is a minimum, start exploring it. And whichever cost is maximum, that the nodes will not get explored. Now find out the cost of each one. That means find out the cost of 1 to 2. Now you have a question. You may have a question that 1 to 2 cost is already given in the matrix. As far as you see this reduction matrix, 1 to 2 cost is what? 10. So 10 is already there. Then what is the reason of finding again cost? Yes, because we wanted to get the minimum cost, reduced cost. The formula for reduced cost, if I wanted to find out the cost of 1 to, cost of 1 comma 2 is equal to cost of 1 comma 2 plus reduction cost R plus R cap. Now this reduction cost of what? C1 comma 2 again. That is C1 comma 2 you already have. What is C1 comma 2? It is 10. So what is reduction cost? It is 25. If you have any reduction, this R cap value, you have to find it out. How can I find this R cap value? If I wanted to find the path of 1 comma 2, cost of 1 comma 2, make first row infinite, second column infinite. Now again apply reduction. Yes, now we'll see how it will. If I find out the R cap, that is R cap 1 comma 2, reduction cost for this. That means I am calculating second node value, second node matrix. So second node matrix reduction cost is what? Make infinite of these values and make infinite of this value. So 1 comma 2 and 2 comma 1 is the same cost. If you find here 1 comma 2 and 2 comma 1 it is the same, right? So you have to make what? Infinite. That means first row will get infinite, second column will be infinite, and this 2 1 also infinite, and all are remaining same values. So these values, after you found this matrix, you have to find out the minimum value again, and the procedure is same to find out the reduction cost. After you find the minimum value, subtract this value with each element of the row, and after you find column 1, subtract each value with this column 1. So then you'll get one matrix, right? That is what? Second matrix. So that the cost you have to find it out, right? Now let's see. So after you reduce, this is the matrix, and state space tree is this one. So now what we'll do is, we'll be going to find out cost of 1 comma 2. So what is the cost of 1 comma 2? Let's see how I'll find C of 1 comma 2. C of 1 comma 2 is C of, from the adjacency matrix, C of 1 comma 2, R plus R cap. So C 1 comma 2 is what? C 1 comma 2 is 10. Plus reduction cost is 25. Now this R cap value you have to find it out. Now find out the minimum value from this matrix. What is the minimum? This is 0, this is 0, 0, 0, 0. And here minimum is 0, minimum 0, 0, 0, 0. That means no minimum, hence it is 0. So 1 comma 2 cost is 35. So right over here, C is equal to 35. Now again calculate 1 comma 3 cost. Now what is 1 comma 3? As far as R cap is considered, now we will be going to make first row is infinite, third column is infinite. Now after you found first row, third column, after you make first row infinite, third column infinite, find out the minimum value from each row, from each column. So whichever node is having minimum, that will write over here, right? Now, so after you have all zeros, you please subtract the values, right? Now you will get the cost something like, so C of 1 comma 3 is equal to, C of 1 comma 3 is equal to 17 plus 25 plus 11. So the cost is 53. So right over here 53. Now again find out C of 1 comma 4 cost. So if you find C 1 comma 4 cost in the same procedure, so these are what the values, and I'm just writing directly because I have explained you the procedure what you have to follow. So you please follow the same procedure, hence you will be getting the cost of each one. So this is the way. Now look at path 1 to 4 is what? First row should be infinite, and fourth column should be infinite, and 4 to 1 should be infinite. The same is follows in all the cost. That means cost 1 2, cost 1 3, cost 1 4, cost 1 5. After you get all this cost, whichever cost is minimum, that path is going to be explored. Now, so among this, what is the minimum? 25 is the minimum. Now again we'll be going to explore from 4. Already tour has completed from 1 to 4. Now what you have to complete? 1 to 4 is finished. Now he can go to 4 to 2. That means it is what? Node number. Let's assume node number 6 7. 6 8. Now take this as 7. Now so 6 node is what describing? He is visiting from 4 to 2, from 4 to 3, from 4 to 5. So now find the cost of 4 to 2, 4 to 3, 4 to 5. So again what you have to do? Now 4 to 2, right? Now that node you have to make what? Infinite. First and second and fourth infinite. So you'll get a cost. Apply the same procedure, you'll get a cost. Now these are the costs: 28, 50, 36. Which is minimum? 28 is minimum. Start exploring it. So what he visited? 1 to 4 is finished, 4 to 2 is finished. Now what he has to visit? Again he has to visit. Now node number 9, node number 10. So 1, 4, 2 is done. Now he has to visit 3 and 5. Now find the cost in between these two. Now we found the cost applying the same formula. It's 52 and 28. 28 is the minimum. Now there is only one node which is left, which is 3. So I wrote directly the cost of it. Now point to be noted very clearly that the upper bound we were taken as infinite. So once you got the cost of it, we'll be updating that 28. As far as knapsack problem is considered, we were updated at each node level. So in traveling salesperson problem will not, because the tour has not finished. That is the reason why we'll not update that upper cost. Once you find the final tour, you will be updating it. Now, according to the bound function, the cost of the solution, if it is greater, if it is greater, all the node values are greater, then we'll be applying the bound function. So 35 is greater than 28. Now kill it. 53 is also greater than from 28. Kill it. So we are not going to kill this 25 because this is the final solution. The path which I am considering is the final solution. So apart from this cost, all other nodes will get killed. So now the final cost of the tour is what? 124, 422, 225, 523, 321. So with the cost of 28, he has visited these vertices in this order. So this is about traveling salesman problem. Thank you all.